Okay, this video is going to be fairly long, but it's going to cover several different questions that you'll have, and they'll always be in sequence whenever I put them in there. But so I wanted to make one because they all kind of deal with each other, they build on each other. Okay, this one asks about bacteria. A culture starts with 8,100 bacteria, and it doubles every 7 hours. So on this one, we're asked to find a model. A model is kind of like an equation or a formula that can predict the number of bacteria after T hours, after a certain number of hours. Okay, so what model that we're going to use here is going to be we've used it before for our population exponential growth model. It's the same one that we're going to use here. Okay, this n of t equals no, and this is the population after a given number of time. The initial population is a big one here. We know our initial population. Our initial population on this one is 8,100. Okay, and then we know that the population at a given time, it's doubled, so twice as much as 8,100. Okay, so we're going to start using this here, growth rate and time. We know the time is 7 hours. We don't know the growth rate. That's what we're trying to determine. Okay, that will be part of our model here. Okay, so we're going to use this one now. So I'm going to write it right here, and here's our model. We're going to start kind of filling in stuff that we know. We know that 8,100 is our n of O. So and then the other thing we know is 16,200 is going to be our n of t, and we know that that number is the case because it's doubled. Doubled 8,100 gives us our 16,200, so we're going to fill that in. And it's the rate times 7. 7 I got from my hours up here. Okay, and that's our time is 7 hours. Okay, now what we're going to do is we're going to solve this one for r. We're going to see if we can determine what our rate is. If we can identify what our rate is, then we can create our formula. Okay, so we're going to divide both sides by 8,100. And the reason why we're going to do that is because we're trying to find what this value is. We're trying to get this out of the exponent, but the first thing we've got to do is kind of get rid of everything else. So we divide both sides by 8,100. Well, 16,200 divided by 8,100 is just 2. We know that because it doubled. So 2 equals e to the 7r. Notice I moved that 7 in front. In mathematics, when we're used to seeing it as a coefficient, as a number in front, so we just moved it in front. It's r times 7 here, and this is 7 times r. It doesn't change its value. Okay, now that we have this, we're going to need to take the natural log of both sides. And the reason why we're doing that is I'm trying to get it out of this exponent here. And I know that if I take the natural log of both sides, it will cancel this e out, okay? So I take the natural log of both sides, and as long as I do it to both sides, I haven't changed its value. These two here are the equivalent. They're the same value. I just added this natural log here because I know that the natural log has a base of e. So natural log e of e cancels each other out. Okay, so that makes it a little bit nicer for us. I'm just left with 7r on this side. Okay, again, that's the natural log of, it has a base of e, so natural log of e cancels out, okay, and then we're left with whatever the exponent is. Well, I've got this one, natural log of 2 is equal to 7 times the rate. Okay, I've got to identify what the natural log of 2 is, so I'm going to plug that part into my calculator. Okay, so I pull out my calculator here. I'm going to clear out what it's got in there. I just need to find the natural log of 2, and here's our natural log button. This is the ln. This is not the log, okay, this is a natural log. So natural log of 2, I push close parentheses, and I just hit enter. It gives me this big long decimal, and I don't want to round that until the very, very end. Okay, so usually you want to go at least 4 decimal places over. So I do that now. I go 4 decimal places over, equals 7r. Now we're just left with a basic equation. We're going to get r all by itself. This is 7 times r. So in order to get rid of that 7, I'm going to divide both sides by 7. So I do that now. Now, if you look back at your calculator, I already have this answer in here. This 0.6931, all I need to do is just go divided by 7. And you notice it says A and S. That indicates it's an answer. It's your previous answer divided by 7. And just hit enter. Now it gives you a big long decimal there as well. Okay, and that's your rate there. So my rate is 0.099 on down the line. Now it asked me to round it to the nearest thousandth, and this is the nearest thousandth, 3 decimal places. So that is my rate in this case. Now I go back to my original exponential growth model here, and this is the model that I'm going to use. I'm just going to fill in the information that I know. I know n of O, that's our 8,100, and time, we want to use one that we don't know the time on, so we can use it all the time if we want to try to find after 8 hours, after 12 hours. So time is going to be, the t is going to remain there, but we know the rate. The rate is this 0.099. So now I fill that in, 8100. Again, that came from right here, my initial bacteria, times the number e raised to the rate, and the rate in this case I got right here. That's what I just solved for, times time. And time will allow us to plug in any time that we want to try to find it. And let's do that. Okay, so this is your function. This is your answer for your function portion of it. Now, the next part will ask us, find the number of bacteria after 12 hours. Well, now that we have this function created for us, the 12 hours is going to be really easy. 12 hours, that's going to be our time. We're just going to plug in 12 for t. So I do that now. I've got that here, and I just plug it in for t. I use my calculator again, and I'm going to plug it in just like I see it here, 8100. E is this one here. It's written in blue. It's right above your ln button, and it's in blue indicating that we have to go second ln. We hit the second button, then ln. That gives me my e. And this is raised to the 0.099 times 12. And I wrote it pretty much like this. I didn't put the 0 in front. You can put the 0 in front. It gets you the same answer. Either way is okay. Then I just hit enter, and that gives me 26,572. So there we go. And now we need to round it, and it asked me to round it to the nearest 100. Okay, so the nearest 100 in this case would be 26,600. Rounding my answer, 26,600 bacteria. Okay, now that we've got that one done, there's one other question that will pop up here as well. And the last question will say, after how many hours will the bacteria reach 21,000? Okay, so in this case, we're trying to solve it for t. We don't know what the t is going to be. So we're going to plug in 21,000 for n of t on this side, because that's going to be our final population, if you will. So I plug that one in here, and again, we're looking for t value now. I've got to try to isolate that, so we're going to we've gone through this process before. I've got to get t all by itself, and it's in the exponent, so I've got to get rid of everything else here. So I'm going to divide both sides by 8100, and if I divide it both sides by 8100, that'll give me this. And now this is, well, again, we don't want to round this until we get close to the end, so 4 decimal places is a good indicator of where you need to stop, and that usually gets you the right answer. Okay, so 2.5926. Okay, now I need to get this out from underneath the exponent, and this was like our previous one that we were just doing. And in order to do that, I take the natural log of both sides. So I take the natural log of both sides. Again, if we do it to one side, we have to do it to the other. And now if we do it to both, we haven't changed its value. And again, the natural log of e cancel out. So we're left with just whatever our exponent is. So here's what we're left with at this point. And we're going to kind of go through the same process after you do a couple of these, or kind of get the hang of it. But we've got this one on the left-hand side we're going to need to plug into our calculator. So I'll pull my calculator back out. Let's clear out what's in there. And again, here's my natural log button. I go natural log 2.5926. Close the parenthesis, and I'll just hit enter here. And that gets me a big long answer. And again, I'll just go to the fourth decimal. 9527 essentially will be my fourth decimal on this one. So here we go, 9527. That's my fourth decimal. Now I'm just going to solve it. I'm trying to find out what t is. So I've got to get t all by itself. This is 0.099 times t. So I'm going to need to divide both sides by that 0.099. So I do that now. And I can take out my calculator here, and I can do that and just go divided by 0.099. I can hit enter, and my answer will be 9.6228. This one asked me to round it to the nearest hour, so I've got 9.62. I just need to round that to the nearest hour. That will round up. So my answer on this case will be 10 hours. After 10 hours, basically it will hit 21,000 bacteria level.